This is a FarmDoc Daily webinar. I'm University of Illinois Extension's Todd Gleason. I'll be your host for the day. Thank you so much for joining us. Today, we'll talk about managing weeds in variable weather conditions, some insights from data mining. Marty Williams is with us from USDA, ARS, and Aaron Hager, a weed scientist from here on the Urbana-Champaign campus of the University of Illinois. And U of I Extension joins us to take us through a set of slides this morning. If you have questions, please do put those into the question box and we'll get them answered either during the webinar or just after we complete it. With that, I think we'll get started right away. Well, one other thing, Jim Baltz, thank you for being here. Jim is behind the scenes and operating the program today. Good morning to you, Marty, and Aaron, thank you for being with us. Marty, I believe you're kicking us off for the day, and we're going to talk a little bit about global climate change up front.
Yeah, good morning, Todd. Appreciate the introduction. Yeah, the Intergovernmental Panel on Climate Change issued a new report this last August, and basically the bottom line of that report was that the climate of our planet is changing at an unprecedented rate, and already some of these changes are irreversible. There is scientific consensus that global temperatures are increasing, the ocean is warming, permanent ice is decreasing, and there's several other changes that include extreme weather occurring more frequently. These changes are driven largely by human activity, and I think it's something that's an issue probably of interest to quite a few folks that are involved in crop production. We're already seeing climate change striking us here at home in the Cornbelt. The annual mean temperatures are increasing. Here's the annual temperature difference from the average since 1890. And you see a slow, steady trend upward over time. Today, we're seeing more frost-free days and more hot days year-round. The map insert on the right is the migrating Illinois map, and that shows what the climate of Illinois might feel like in the coming decades. And just exactly where that's positioned depends on the emission scenario. But by the end of the century, it looks like those of us in Illinois, or those of us who will be in Illinois at that end of the century, are on track to have a climate that feels a lot more like East Texas. And the precipitation is changing as well, and it's changing seasonally. Overall, for the Midwest, we're expected to have a greater amount of precipitation, but the majority of that coming in increased precipitation during the winter and spring, whereas actually during the summer we're headed on track to have less rainfall during the summer. We're also seeing more extreme rainfall events. Over the last century, this insert shows you the number of very heavy rainfall events, and those instances have increased 37% in the Corn Belt. There's some of you that might have, those of our listeners near Champaign-Urbana might have a recollection of a recent experience. Aaron, do you recall what that was? It might be a good example of an extreme rainfall event.
Well, just in our two growing seasons ago, actually in 2019, we had excessive precipitation in the spring of the year, which delayed a lot of both weed control program implementations as well as planting time. And a lot of acres ultimately that were not able to be planted and had to take a planting provision. And driving around the state, some of those areas, the weeds were quite well managed on, and other examples where it didn't appear like a lot had been done to those fields, and added a tremendous amount of weed seed back into the soil seed bank that, you know, those farmers, those growers on those acres are going to have to contend with that now for years into the future.
Mm-hmm. Yeah. And even just this last year, I guess that was probably about 7 weeks ago, Gibson City got the 9 to 11 inches of rainfall in a very short period of time. So unfortunately, the models indicate that this trend will be worsening over time. So Aaron and I both work on weeds, and there's a number of issues when we think about climate change, a few different questions that pop pop up in our minds, and this is just a short list here. I guess I'd like to draw your attention to a couple on this list. That first question would be, how will herbicide efficacy be affected? And Aaron, why don't you provide some insight on why that'd be an important question to ask?
Well, well, actually, for a lot of reasons. We used to say years and years ago that, looking back in hindsight, 19 and you fill in, 1985, 1987, fill in your year. Well, that was a really good year for black nightshade. Or maybe, 2020 was a really good year that we saw a lot of shatter cane that came up later. But with respect to our focus here today on climate change and how that affects weed management, certainly we have a lot of significant challenges now, even apart from climate change. One of the most daunting issues that many farmers, not only in Illinois, but across much of the Corn Belt, even virtually all regions of the Midwest, are contending with are weed populations and/or species that have evolved resistance to various herbicides. So that obviously it has had an adverse effect on herbicide efficacy, simply from an evolutionary biology standpoint. But how will climate change affect herbicide efficacy? Well, if you think about it, just a little bit, if we continue to rely on soil residual herbicides to try to give us extended weed control, it really doesn't matter when those products are applied. They all have to be in the soil solution or in a vapor phase in order to be effective, in order to be taken up by that germinating seedling. The most common way we do that now is we wait for a rainfall event. And so in the spring of the year, if the model predictions are for more frequent but more heavy rain in the spring of the year, the likelihood of receiving that incorporating rainfall certainly could go up. But if the intensity of that rainfall is now much greater, we could possibly see losses of herbicides. Maybe under flooded field conditions, we'll see anaerobic conditions, and we may see accelerated degradation of some products. If we see excessive runoff from fields, we may be physically losing some of that applied herbicide material as it runs off in surface water. So a lot of different ways that our climate change is going to really impact this efficacy.
Yeah, those are great points, Aaron. And one way that we can ask these type of questions is conduct experiments where we control different types of kind of control the situation and implement different types of treatments and different types of environmental conditions. However, that can be quite expensive. If we're wanting to look at something that captures a broad range of sort of climate conditions, you and I kind of thought of a new way to tackle that kind of problem, which I'll be just moving to in a moment here. Another key question I just want to point out before I go to the next slide is that how will crop weed interactions change? And that's another issue that it can have significant impact, because we have pretty much every field every year has some weeds out there, and oftentimes they're not completely controlled. And so while the types of environmental factors that are going to impact the crop, they're also going to be impacting the weed population. So this issue of how do you study this kind of issue where you have, where you want to understand how something like climate might affect things. Well, one way we can get at is to consider some of the weather variation that we've observed. And we, Aaron and I came up with a good idea of finding some data that captured a lot of different weed control measures under a range of different weather environments. And that was using the university's crop sciences department herbicide evaluation program. And Aaron, this is a program that you've managed for a number of years. I'm going to let you explain what you have there.
Yeah, it's a program, Marty, that actually our group has had in existence literally 4 decades. Probably began back in the late 60s to 1970s timeframe. And it simply is the program where we partner with many in the industry to try to look at new active ingredients, try to evaluate where they may fit in terms of a weed control spectrum that farmers in Illinois and across the Midwest may be able to receive benefit from. We look at potential for crop response, damage from these products. So in any given year, we may have anywhere from on a low year, slow year, whatever you want to call it, maybe 50 to 60 different trials. Historically in the past, when we've had a lot of others in the herbicide discovery industry, sometimes we'll have over 200 trials. And it's simply, again, what we do is we put together protocols for field applications. We look at different active ingredients. They may be single products. They may be in combination. It could be looking at different types of spray additives that are added with these various treatments to see how performance is affected by these different types of additives. So a lot of different ways that we have done these protocols down through the years. And once all the treatments are applied, it then comes down to making the observations, making the weed control assessments, making the crop response assessments. And those typically will make at least 3 observations once the treatments are applied. Depending on the protocol, we may do that more frequently than just 3 evaluations. So you can imagine that over time, when you have this many protocols and experiments that are put out every year, these numbers of trials can substantially build up over time.
Yeah. And so while those individual trials have fulfilled their individual objectives, they met the criteria that, they provide the information that was needed from that individual trial. What's the extent, Aaron, that you've seen that used beyond that, and used that data used elsewhere? Has it, prior to this, how has it been used?
A lot of times what these data end up going are being used for, number one, of course, they satisfy, or hopefully satisfy, the objectives of the experiment, that the individual companies who had treatments in there are able to look at the data then and get some value, some use out of it, and better understanding of their products. They'll also be used as we formulate here at the University of Illinois our extension weed management recommendations. But by and large, we'll make a report available every year, and that's basically where they sit. It's not necessarily that we're writing any kind of a journal article from these data. So for a lot of times, they'll have immediate utility, let's say, for example. But in terms of long-term utility or usefulness, up until the ideas that you and I talked about a couple of years ago, we really didn't use them very much after that. So probably within a year, maybe 2 years at the outset is a lot of the utility of these data, but they're still there. And you and I had several office conversations about, golly, is there another way that we can still extract new value from these? Yeah,
we have to give a shout out to Doug Maxwell, who had the foresight back in the early 1990s to compile that into a single database. So that really lent itself well to the graduate student that we got on board of this project, Chris Landau, who graduated last May. He had a project, and I want to, Aaron, I want to share with you 2 lessons that we've learned from utilizing this data, this historic data set that represented we have it over 3,000 individual trials since 1992 and over 50,000 observations. Pretty robust data set, particularly when we want to capture a range of different weather conditions, which we certainly got over that time period. And so lesson number 1 I'd like to share with you is that future efficacy of pre-emergence herbicides is threatened by more variable weather. So let's, Aaron, would you like to share with the group sort of that significance of what happens after a pre-emergence herbicide is applied, and how that might influence the performance of it?
Right. Well, a lot of it is going to depend upon what the soil conditions are when the application is made, but that's going to be impacted on what the previous weather conditions were, as well as what the future weather conditions are. And so, as we suggested earlier, when we make that application to the soil surface, one way or the other, that material has to be moved into the solution for it to be made available. We can do that either mechanically, which we term incorporation of the surface application, or we can wait for that rainfall event. It really becomes important because we really don't have an indefinite amount of time between when we make the application and then when we have to have the incorporation event. So usually, historically, what we have suggested would be, we need somewhere between about a half inch to an inch of precipitation, ideally within about 5 to 7 days of when that application is made. So if we're less precipitation than that, or if it's not received until days later, then we can generally expect to see a reduced level of herbicide efficacy compared with if we would have that ideal scenario. Mm-hmm. And so if you think about the extremes of this, we talked earlier about the effects of 2019 when we had excessive precipitation. Well, if you go back in history to 2012, it was the exact opposite. We had very, very dry conditions. And so in both of these extremes, we can really get a good snapshot, a good picture of how variability or extreme weather events can have a pretty significant influence on pre-emergence herbicide efficacy.
Yeah, and that's the neat part about this research is that we were able to, well, and Chris led up this work, quantify exactly some of those details in the weather, particularly as it relates to, if you look at the graph on the right side here, as it relates to rainfall and on the x-axis and soil temperature on the y-axis, we were able to quantify just how much rainfall was required and how that was influenced by temperature on the performance of specific corn herbicide products on specific weeds. So this is just one example, acetochlor plus atrazine, and particularly how it works on common lamb's quarters. And I'll just briefly describe the coloring here on the graph is the darker the color, the higher level of controlling that weed. And as you get to the lighter colors, from blues to the greens to the yellow, represents basically failure of that performance, that herbicide, if I can catch that correctly. And so for a number of important weeds and a number of important widely used products, we were actually able to quantify just how much rainfall was needed, particularly given what the soil temperature was. So this is something that provides a much clearer understanding of at least how these weather factors influence performance of products. And the challenge is a lot of the forecast weather we have coming that is predicted in the future may challenge the efficacy. And this is not considering herbicide resistance at all, just availability, bioavailability of that product in the soil solution is going to challenge some of these important pre-emergence herbicides. All right, let's move on to lesson number 2 that we learned from utilizing the data from the herbicide evaluation program. And the second lesson is that diminishing weed control exacerbates crop yield loss to adverse weather. I have to step back a moment here and share that there's been some great research done on how climate change may impact yield of some of our important agronomic crops. Both soybean represented pictorially here, as well as corn. And there's a lot of research just kind of give us an understanding of as temperatures increase, as greenhouse gases increase, whether it's CO2, which can provide some fertilization for C3 crops like soybean, but other greenhouse gases such as ozone, which can be detrimental to crop performance, and the impact on rainfall, and whether it's inadequate rainfall or heavy rainfall events that lead to flooding. There's a pretty good understanding of how these might impact future crop yields. Although all of these projections, Aaron and I noticed, assume that the crop is weed-free. And based on our experience, we feel like that's a pretty big assumption because, as I mentioned earlier, pretty much, I have yet to be in a field that I'm certain that there's a zero weed seed bank. And for pretty much every field, there's some pretty significant effort going to managing the weeds. And a challenge that we're having, particularly as herbicide resistance gains more traction, is that accomplishing complete weed control is getting quite difficult. So with this research project, we asked the question, well, there's things that are impacting the crop that's pretty well known, but these factors that are impacting crop are also going to be impacting the weed community. And if we think about scenarios where we do not have complete weed control, which based on my observation, just driving down the highway at a highway speed, there's plenty of fields out there that have incomplete weed control. And so our question was, what combinations of what really drives yield loss in our important crops? And we just published a paper on corn yield loss. And what we found was that the conditions that result in crop losses that most are well aware of. If you have particularly hot conditions during silking or tasseling, or particularly drought conditions during this important stage where the crop is shifting from vegetative to reproductive period, can have a significant impact on crop yields. Well, what we found is that actually the incomplete weed control, if we have less than complete weed control, that small amount of weed competition exacerbates those losses from that adverse weather. And again, this is a bit of a concern because most of the climate predictions indicate our summers are going to become hotter and drier, particularly at the time later in the season when the crop will be flowering. And short of really transforming how we manage weeds, we see for the near future, we're still going to be a real battle to have complete weed control or near complete weed control. So this gives us some reason to be concerned, but also give us sort of motivation, not us, but everybody, motivation to come up with new systems to manage weeds.
Marty, you bring up some very good points about that less than complete weed control, because it's very evident that we're not necessarily achieving that level of weed control. And it's very evident as you drive, and look at fields at this time of year. One thing that we don't really talk too much about in this webinar or in either one of these publications, but you had it listed earlier about, how can climate affect weed management? And one would be, what about weed species shifts? And, a lot of folks may or may not know, our dominant amaranthus species here across most of the Midwest is water hemp. Very easy to find water hemp right now in cornfields and soybean fields. But there's another one that's even more challenging than water hemp, and that's called Palmer amaranth. And it doesn't take a whole lot of searching online searching to learn how challenging Palmer can be. This is a species that literally has put people out of business because they didn't really concern themselves about those few scattered plants that remained at the end of the growing season. Well, one of the issues, of course, with either water hemp or Palmer is the tremendous seed load that these females can produce. You're talking hundreds of thousands of seeds that these females are making. We'll spread those seeds around at this time of year as we harvest fields. Combine goes through these fields. Where are we going with this? Well, Palmer actually evolved in the Sonoran Desert. It's not a native of the Midwest. It's not a native of the southeastern United States, but it certainly has gained a foothold, especially in areas, for example, the Boot Heel of Missouri, Arkansas, Georgia, become very, very challenging species. We do have it here in Illinois. It has caused some very devastating yield losses because of how competitive this species is. But the reason I bring all this up is that, all these iterations of differences in the climate, just yesterday I saw a news article that Palmer amaranth has now been found in the province of Manitoba in Canada. Mm-hmm. So just think about, a desert evolved species now potentially being able to find a home north of the border. And all these changes here that we talk about, whether it be climate or zero tolerance threshold at the end of the season, if we allow some of these, quote unquote, new species or species that we haven't really contended with previously, we allow those few escapes, to survive and reproduce seed. Now we're just simply augmenting that seed bank. And this is going to be something that we're going to continue to be challenged with as all these other factors related to climate change continue to get more and more keen over time.
Yeah, that's a great point, Aaron. And speaking of Palmer, that's really great research done here at the University of Illinois. Well, actually, it was my colleague who was with ARS at one time, Dr. Adam Davis, did some nice work to show that, the only reason there's nothing keeping Palmer from doing very well here. And it's just a matter of, where is that seed, where does that seed disperse to? And
well, I mean, and you think about a desert evolved species moving into a new geographic area. Well, what does our climate prediction tell us?
Right.
We may be more like that, more southern, more climate, in the middle part of the century, where that species actually evolved. So, right. Once it's here, it'll begin to evolve to whatever environment that it's growing in.
Yeah, and that's a good point. It's worth raising that most of our weed species have enormous genetic diversity, and also a great deal of phenotypic plasticity. So, there's lots of the genetic diversity provides all sorts of opportunities for at least some of those individuals to perhaps take advantage of some change in the condition, as well as the phenotypic plasticity. Some may be able to adapt in small ways, just based on the genetic structure they currently have. So probably a lot, certainly, relative to our crops, there's a lot more diversity there and a lot more opportunities for just a few individuals to perhaps persist.
Kind of think of it this way: as these problematic weed species are evolving to favor certain genes that allow them to survive herbicide, i.e. evolve herbicide resistance. At the same time, they are experimenting with different genetic combinations that allow them to survive in higher CO2 environments during drier parts of the later portion of the growing season, or perhaps even learning to adapt to very wet conditions in the spring.
Right. Yeah. Well, I think we're kind of building on our next slide here of the need for diversification. And what do you see, Aaron, as the sort of short-term and long-term? How do we think about diversifying our weed management? What are you seeing as the what's that going to look like?
It's something that even in the face of the continued evolution of herbicide resistance, I think at least in the foreseeable future, we're going to continue to rely fairly heavily on herbicides for, that first primary defense, if you would, against weed interference and weed competition. But combined again with our changing climate, the evolving resistance, we're going to be forced into asking ourselves, what else can we do? In addition to herbicides, what other practices can we do to try to ensure that by the end of the growing season that there is no seed return, there is no weed seed return? A lot of folks now are thinking about cover crops. Can that be a component of it? Certainly can be. Is that a one solution? Certainly not. It may be the concept of harvest weed seed control. Can that work? Certainly that can help. But if you think about this from an evolutionary standpoint, eventually weeds will adapt to that as well. So as many different angles, as many different approaches, as many different tools that we can incorporate in any one season to try to ensure that we get to that level, that there's no weed seed return at the end of the year, that's how you win. If we're simply waiting around for this new active ingredient to come into the marketplace and think that's going to solve all of our problems, then maybe we haven't learned our lessons yet, because we've done that repeatedly over time and nature has always come out on top.
Yeah. Yep. So a pretty high need for innovation as well. And luckily there are some, a diverse collection of innovation. You mentioned a few things there are now some products coming out. The Redicop integrated seed, it's a cage mill that attaches to the back of the combine that does a pretty good job of pulverizing chaff that's come through. That is one technique at limiting kind of some of that seed that could be returned and reducing that. But there's a whole host of other things that type of new technologies coming. I just saw something recently with some of the autonomous weed management, some of these weeding robots that that don't necessarily use an herbicide, but can also use other tools with heat or flames or knives. And there's some adoption of that going on already in the West Coast and some of the high value veg crop production. How will we see that here in the Midwest? Well, time will tell. There's, we'll see, but there's some neat, some promising other innovations, but we just don't want to be counting on that one thing alone to solve the problem. Likely we're going to have a combination and diversify so we maintain the useful life of all the products that are available.
Hey, think the way I think about this, these large expanses of land that we pull into with these extremely expensive pieces of equipment to work the ground, to plant these seeds of the next corn crop or the next soybean crop. I grew up on a farm and we call these areas their fields, right? Mm-hmm. But think of them this way. These are biological systems. And by definition, biological systems are never static. They're always changing. They're always evolving. If you think back of the weed spectrum that perhaps we dealt with predominantly 30 years ago, that's really, in many cases, not the same spectrum that gives us the most challenges these days. So a lot of times weeds have actually evolved both to herbicides, but also to farming practices. And the way that we, again, try to stay in front of these things is disrupting these systems that we're only using certain tools, whether they be tillage tools, whether they be herbicides, and add more diversity. The more diversity that we have, the better able we are to slow this evolutionary process of weeds adapting to these practices.
Absolutely. Yeah. So we're wrapping things up here. I do want to give you a return to the research that we were doing here, and all the research that we've talked about is actually from the Illinois Herbicide Evaluation Program. However, that program is not unique in the U.S. Most land-grant universities have a similar type of herbicide evaluation program that have been doing a lot of the same things that have archived data that would represent a greater diversity of soils, of weather, of crop management practices. And Aaron and I are building a collaborative team with extension weed scientists from states throughout the Corn Belt and beyond to build a much more comprehensive database, so we can even do more powerful analyses to gain useful knowledge from data that's kind of ripe for potential. So we just got back from a meeting just yesterday and got to visit with many of our colleagues on this very project. So there'll be more to come in the near future, and excited to have Chris leading up that effort as a postdoc with us. And hopefully we'll plan on more to come in the future, more reports on this.
Marty, I'll just say one thing about this. You and I, we kind of joke with each other about this. Started out as a hallway conversation years ago, and we've got a couple of papers that have been accepted already. We had a couple more sort of warming up in the bullpen. But looking at the map here, look at all those stars out there. And now we've got the collaborative expertise of so many other scientists thinking about these things. And the beauty of it is, we'll not only have a larger data set to try to look at, but we now have so many other excellent weed scientists to collaborate with. And hey, how would you like to see these data used? Here's some ideas that we have. Here's some examples of what we've done. You and I haven't covered the waterfront. We've tried to, but we haven't done it yet. But with the other scientists on board with us, kind of the sky's the limit, really.
Right. And you may notice, I got to put a shout out to the star that looks like it's over Lake Erie or Ontario. That's actually, we've got a scientist, University of Guelph in Canada.
In Ontario, yep.
And so it's like a binational effort here on.
Yep.
And we're pretty excited about the future of what this research can provide. And especially if we tap into the wider expertise of these groups, because it's it's pretty humbling, the collective amount of experience as you get more of these folks involved. All right, well, that wraps up the portion that Aaron and I had. Thank you for your attention. We've got some contact information if you want to reach out to either of us. If you're really interested in the latest paper, there's the citation on it. It's open access, so feel free to download that and shoot us a question or give us a call. I'll be happy to chat about it. Thank you.
Thank you too. Marty Williams and Aaron Hager have been your presenters for this FarmDoc Daily webinar. We would like to thank our sponsors for the day. They help to make this possible. They include Compeer Financial, TIA, the Center for Farmland Research, here on the Urbana-Champaign campus of the U of I. That's at farmland.illinois.edu. Corteva Agri-Sciences, FarmGradit Illinois, the Illinois Soybean Association, FS Growmark, the Illinois Corn Growers, the Gardner Agricultural Policy Program. That's in the Ag Econ department here on campus as well. And of course, the Ag Econ Department, Agricultural and Consumer Economics, also known as ACE in the College of Agricultural, Consumer, and Environmental Sciences. There are some upcoming webinars next week, and you're already signed up for these because you're signed up for the webinar series, so no need to worry about getting signed up. You will get an email. Next week, we'll talk about MRTN. That's the maximum return to nitrogen, or the in-rate calculator that many of you probably already used. Emerson Nafziger and Dan Schaefer will be here. They're wondering whether the rate for corn is high enough. They'll talk about that. And then the following week on the 14th, again Thursdays at 11 a.m., Bob Ray, Dale Latz, and Nick Paulson will be here to talk about grain returns for 21 and 22. And a couple of new ones have been added. So there are two more that are in the list now for October 21st and the 28th. Bob Ray will be back on the 21st talking about some of the changes in the tax code. And there are several of them for this calendar year that farmers will need to be aware of. And then on the 28th, we'll wrap up by talking with Bruce Sherrick and Gary Schnitke about factors affecting the farmland markets. I would like to thank again our panelists for the day, including Aaron Hager and Marty Williams. There are some questions for the two of you. I'm wondering on this question about mitigation in the future and whether there is anything to be learned from what those who are raising corn and soybeans in the South, whether that's in the southern part of the United States or in South America, particularly in the more northern climes where it's much warmer, of Brazil, that you might be able to look at as a way to mitigate some of the issues that could come in the future as climate changes here in the state and across the Midwest.
Yeah, that's a great question, Todd. I haven't seen any kind of data analysis on that, but that's part of our interest in building this network and being able to pull in data beyond Illinois, particularly South. One of our collaborators, I don't know if I had it on the map there, but is at Texas A&M University. So that most likely one would think there's reason to believe that might give us having data like that included in our research might shed a little bit of a light onto what type of future we could be dealing with. At least some little bit of a look into the future, perhaps.
Aaron, for you, because Marty mentioned the seed crusher that can be it can be a pull type, the ones I've seen, but can be adapted to the back end of a combine, where simply the chaff rolls through a crusher that breaks the seed apart. How long does it really take for weeds to adapt to cultural practices? And I guess maybe I'm thinking about what has happened with water hemp and the way it is adapted to when it emerges across the season in the state of Illinois.
That's a really good question, Todd. And the simple fact, or the simple answer, is that yes, eventually they do adapt. The speed at which the adaptation takes place is really dependent on a whole host of factors, and it's kind of perilous, I guess, to try to put any numbers to it. But I've got an example of this. There was actually a paper published here back in is either late 1960s or early 1970s, which made a prediction that Illinois farmers would never have to contend with giant ragweed as a weed problem in cornfields or soybean fields. Now, if you farm in the northern part of Illinois or certain river bottoms of Illinois, that probably caught your attention because you have giant ragweed populations with which you deal with annually. But the focus of that work was looking at the emergence pattern of giant ragweed. And essentially what they did is they made multiple collections around the state and did what's called a common garden experiment, where they planted these different accessions at one location. And they kept track of how long they emerged in the spring. And essentially they were done emerging by May 1st. Now, we said earlier that that work was done back in the late 1960s, but think about how we farmed in the late 1960s. You know, we weren't planting most of the corn and soybean crop by mid-April. We had plantings that were very common throughout the month of May. Well, and back in the late 60s and early 70s, we worked most of the ground before we planted it. So therefore, if you had a weed that had emerged, you worked the ground before you planted. That was the basis of that summary from that paper that was published so many years ago. Well, a few years back, that experiment was repeated. So accessions or collections of giant ragweed were made across fields in Illinois, brought back for a common garden experiment. The difference this time around, though, was that the researchers also included accessions of giant ragweed that had been collected from areas that had never been farmed. So, for example, a woodlot somewhere, maybe the corner of a cemetery somewhere. These populations had never been exposed to agricultural production practices. This has nothing to do with herbicide resistance, okay? And so when they repeated this experiment, what they found is that the giant ragweed collections or accessions that came from agricultural fields, now they had emergence by May 1st, like it always had, but they saw prolonged emergence. They saw emergence that continued throughout the month of June, even into July. But the few accessions that were collected from areas that had never been farmed, they came up and stopped at May 1st. So in other words, giant ragweed as a species over a period of 40, 50 years has simply adapted to how we farm these days. And you mentioned water hemp, another example of a species that is very adaptable to how we farm. And certainly one way that we have seen this evolutionary adaptability is in its evolution of many of the herbicides that were once previously effective for it.
And one final question for you, and if you could bring up that last slide for me, I would appreciate it as well. This one has to do with the mitigation things that producers might be able to do today. For instance, Aaron, you often, when you and I talk in an interview, we'll discuss the importance of cleaning a combine out from before moving from one field to another. What kinds of things can producers do today that might be helpful for the future?
I think one thing, Todd, right off the bat is just simply the recognition of the fact that seeds are going to move, whether it be by practices that farmers are doing, moving weed seeds through tillage equipment, through combines. That certainly is a very visible, easy way to see seed movement. But seeds are going to move in other ways. They're going to move in migrating waterfowl, for example. They're going to move by movement of water. So recognizing the fact that, again, their populations last year may not always be the same populations that they're going to contend with this year. For example, if you had a scenario where in 2021 you had a herbicide that was very effective on your problem weed species, well, what happens over the wintertime after harvest when we're not paying attention because we're doing other things, and somehow this new seed has been deposited in the field? Maybe there's a flock of geese that fed in that field for several days, and they deposited seeds from 2,000 miles from here. Well, now you've got the start of a new problem. And scouting is certainly a good effort before application, after application. If you see changes taking place, don't just assume that there was something wrong with the application. For example, this may be that change, evolutionary change taking place, and try to adjust your program as fast as possible and stay in front of these changes, because it's always easier to try to manage a problem before it actually happens than try to fix the problem after it happens.
Thank you, Aaron, and thank you, Marty. I appreciate it. If you could bring up the second to last slide as well. Thank you all for joining us today here on this FarmDoc Daily webinar series. Just a reminder that you can find these webinars in the archive on the FarmDoc Daily website, but there is kind of a sneaky way to get back to them. It's down in the bottom corner there under YouTube. So if you go to youtube.com and then /FarmDoc video, you'll find the archives of all of these videos, along with the 5-minute farm docs that are produced by the ag economist and crop scientist here on the Urbana-Champaign campus of the University of Illinois. A few other things as well. Again, that's youtube.com/FarmDoc video. It's down there in the corner. On behalf of Marty Williams and Aaron Hager and Jim Baltz, who has been behind the scenes, again, thank you so much for joining us today. I've been your MC and host, University of Illinois Extension's Todd Gleason.